Hello there, this is the intern, and today we'll be talking about some underlying concepts of blockchain, how a blockchain is made, and how secure they really are.
Kicking off with hash functions. A hash function is basically a mathematical expression that converts a given data into a number, also known as a hash value. Hash functions are widely used in computer science to find, search, and delete stored data because comparing numbers are much faster than comparing raw data. But here it would be doing more than that. Hash functions used in blockchains are generally cryptographic hash functions, which take up a lot of time to evaluate and are a lot more complex. Once a hash value is computed, it is said to be the proof of work for a specific block. For the sake of simplicity, let's just add the position of the appearance of the alphabets in the word Miyagi to obtain our hash value. This will be our hash function throughout today's video. Now there could be another word that would make the same hash value. This is known as collisions. So yes, the hash functions used in blockchains are far more complex than this so as to avoid collisions. Moving on to how the blockchain is really made. Let's say the first bit of data we are inserting in the chain is the word Arabia. Its corresponding hash value is calculated, which is known as the proof of work, and is moved to the first block to be ever made in the chain. This block is called the Genesis block. Next up, we have the word Siberia. This time we would be calculating the hash value and also adding the hash value of the previous block to produce a new proof of work for this block. We continue this by adding another block in the chain with the data of Austria. This creates a blockchain with 3 blocks of data embedded in it. Since the blockchain is a distributed system of data storage, it is possible to publicly view all this data and their respective proof of work. Now let's take a look at what an attacker would actually have to do to break this distributed system of data. This attacker privately creates his own blockchain and makes a modification in the second block by changing the data from Siberia to Algeria. This results in the attacker to recalculate this block and all consecutive blocks' proof of work. Now the big question is, will he succeed in tampering the chain? Since the blockchain is a distributed system of data, making changes to the blockchain requires collective consensus about its integrity. In other words, you will have to make at least 51% of the other blockchain users to agree that your chain is legit and the main chain is false, which is literally impossible, and your chain gets rejected right away. The second reason for your blockchain to get rejected is that the time you used up to modify and recalculate your proof of work on the chain was already used up to create the main chain even bigger, with more data in it. You have to be faster than everyone in the network to calculate your proof of work, which is very unlikely for a modern day computer to do. This brings us to the conclusion that even without a head authority, a blockchain can be collectively maintained in a much safe and sound manner than a centralized database. That's all for today. I'll catch you up in the next segment.